So, what is integration by substitution mean? Integration by substitution mean we use it to simplify a difficult integral, which we involve changing part of the expression into a new variable u, and then we make the integral easier to solve. After solving, we substitute back to the original variable. To solve the integral of 2x times x exponent 2 plus 1 power of 50 with respect to x, we use a method called u substitution to simplify the math. First, we choose the complicated expression inside the parentheses to be our u, giving us u equal to x exponent 2 plus 1. Next, we take the derivative of u with respect to x, which result in du dx equal to 2x. Looking back at our original problem, we can see the remaining 2x and the x components perfectly match our derivatives, allowing us to substitute them out and rewrite the entire problem in terms of u as the integral of u power of 50 du. From here, we apply the standard integration power rule by adding 1 to the exponent and dividing by that new number, which give us u power of 51 over 51, plus the constant of integration c. Finally, we swap the original x expression back in for u to get the final answer. So, the final answer is x exponent 2 plus 1 power of 51 over 51 plus c. To solve the integral of x squared times the quantity x cubed minus 4 raised to the power of 5, we use the method called U substitution. This method helps simplify complicated expressions into an easier form. First, we let the expression inside the bracket, which is x cubed minus 4, be represented by u. Then, we differentiate u and obtain 3x squared dx. Since the original question only contains x squared dx, we rewrite it as 1/3 du. After substituting everything into the integral, the equation becomes 1/3 times the integral of u raised to the 5th power. Next, we apply the power rules of integration by increasing the exponent by 1 and dividing by the new exponent. This gives us u to the 6th power over 6. Multiplying by 1/3 gives the result u to the 6th power over 18. Finally, we replace u with the original expression x cubed minus 4 and add the constant of integration. Therefore, the final answer is x cubed minus 4 raised to the 6th power over 18 plus c. How about integration by part? Integration by part means we use it when the integral is product of two different functions. We split the expression into two parts, which is u and dv. And then we solve step by step to get the final answer. To evaluate the integral of xe exponent x with respect to x, we apply the integration by parts method, which is based on the formula. First, we choose our components by setting u equal to x and dv equal to e exponent x dx. Next, if we find their respective counterparts by differentiating u to get du equal to 1 and integrating dv to find v equal to e exponent x. Plug plug these terms into the integration by parts formula, gives us the expression that since the integral of e exponent x is simply e exponent x, the equation simplifies directly to xe exponent x minus e exponent x. Finally, we add the constant of integration to complete the antiderivative, yielding the final answer x e exponent x minus e exponent x plus c. To solve the integral of x cubed times the natural log of x, we use the method called integration by parts. This method is useful when the question involves two different functions multiplied together, especially a logarithmic and algebraic functions. First, we choose the natural log of x as u and x cubed as dv because logarithmic functions are usually chosen as u. Next, we differentiate the natural log of x and integrate x cubed. After that, we substitute all the values into the integration by parts formula. We then simplify the new integral by reducing the expression into a simpler form. The remaining integral becomes easier to solve because it only involves x cubed. After integrating x cubed, we combine all the terms together carefully. Finally, we obtain the final answer, which is 1/4 x to the power of 4 times the natural log of x minus x to the power of 4 over 16 plus the constant of integration, c.